In this video, we're going to learn how to simplify square roots. One thing we need to do when we simplify square roots is to put them in simple radical form. A square root is in simplest radical form when all perfect square roots have been factored out and there are no square roots in the denominator. Now, we use simple radical form because it provides a clear representation of the root. And not leaving square roots in the denominator is a standard practice and helps make it easier to combine expressions. Okay, when we put square roots in simple radical form, we are factoring out all the perfect square roots. So for the square root of 44, I want to think of two numbers that multiply to make 44, and I want one of those numbers to be a perfect square root. Well, the square root of 44 equals the square root of 4 times the square root of 11. Now this is going to help us put the square root into simple radical form because 4 is a perfect square root. So the square root of 44 equals 2 times the square root of 11. And that 2 is now a regular 2 because the square root of 4 equals 2. So we put the square root of 44 into simple radical form by breaking it down into two factors, one of which was a perfect square root, and then we simplified the square root into a whole number. All right, for the square root of 40, we're trying to think of two numbers that multiply to make 40. Now there's more than one pair that multiplies to make 40. We have 5 times 8. We have 4 times 10. And looking this over, we notice that the only perfect square root of these four numbers is the 4. So we're going to use 4 times 10 instead of 5 times 8. So the square root of 40 equals the square root of 4 times the square root of 10. Now the square root of 4 equals a plain old 2. So this equals 2 times the square root of 10. Now we could keep going, but the factors of 10 are 2 and 5, other than 1 and 10. And neither of those numbers are perfect square roots. So we have it in simple radical form. So the square root of 40 equals 2 times the square root of 10. All right, the square root of 48. Well, let's see, that equals the square root of 4 times the square root of 12. You may have thought of another pair that also works, but I wanted to point something out, so we'll start with 4 and 12. Well, the square root of 4, that equals a plain old 2. So this equals 2 times the square root of 12. Now, unfortunately, we're not done here because there's a perfect square root that's a factor of 12, because 12 equals 4 times 3. Okay, so that 2 tags along, and the square root of 12 equals the square root of 4 times the square root of 3. And 4 is a perfect square root. So now we have this plain old 2 from before. The square root of 4 turns into another 2. And then we have the square root of 3. And we just multiply the 2 times 2. So the square root of 48 equals 4 times the square root of 3. Now, we could have chosen a better pair here and done it in one step, because 48 also equals 16 times 3. And 16 is a perfect square root. So the square root of 16 equals 4 times the square root of 3. But the long root is fine also, just took a little bit longer. All right, square root of 15. We think of two numbers that multiply to make 15, and that would be 5 times 3. But neither of those numbers are perfect square roots. So we don't need to do anything to this. So not all numbers can be broken down further in a simple radical form. So the square root of 15 is just the square root of 15. All right, here we're starting with the square root of 28, but with a 2 in front. So 2 times the square root of 28. So square root of 28, that equals the square root of 4 times the square root of 7. And that's a good way to break it down because, once again, 4 is a perfect square root. So that 2 just tags along. The square root of 4 turns into a 2. And then we have the square root of 7. So 2 times the square root of 28 equals 4 times the square root of 7. And we can simplify fractions inside of square roots. And when the square root is over the entire fraction, we could break it down so that's over the numerator and over the denominator separately. And the square root of 4 equals 2, and the square root of 169 equals 13. So in this case, both the numerator and the denominator broke down into whole numbers. So the square root of 3 over 49 equals the square root of 3 over the square root of 49. And 49 is a perfect square root, but 3 is not, so that would be the square root of 3 over 7. Now, we are not allowed to leave square roots in the denominator of fractions. So we need to simplify this fraction so that it does not have a square root in the denominator. Now, the method we can use is we're going to multiply the top and bottom by the square root here that's in the denominator on the top and on the bottom. You'll see why this is helpful in just a moment. But let's take a moment to explain why we're allowed to do that. The square root of 6 over the square root of 6, that equals the number 1. And when you multiply something by 1, it doesn't change what you started with. It might change the way it looks in this case, but it's still the same. Okay, when we multiply two fractions, we multiply straight across the top and straight across the bottom. So multiplying across the top, we get 7 times the square root of 6. We can't combine those because that 6 is actually not a 6. It's a square root of 6. And the square root of 6 times the square root of 6 equals the square root of 36. And the square root of 36 is a perfect square root. It equals 6. Now we are not allowed to cross these 6's off because the 1 in the numerator is not really 6. It's the square root of 6. And we could try to break down that 6 into the square root of 2 times the square root of 3. But neither of those is a perfect square root, so that wouldn't do any good. All right, and notice we do not have a square root in the denominator. So we have it in simplest radical form. Oh, one other comment here. We are not allowed to cancel these 6's. Because once again, that 6 in the numerator is not actually 6. It's the square root of 6. And one other thing. Notice here that when we multiplied the square root of 6 by the square root of 6, we ended up with 6. And that always happens. For instance, if we multiplied the square root of 17 by the square root of 17, that would just equal 17. So in that situation, we don't need to work out the middle step like we did here. We can just go straight to the answer. All right, moving on. We'll break this down into two square roots, one in the numerator and one in the denominator. Square root of 121 is 11. But the square root of 2 is not a perfect square root. So unfortunately, we have a square root in the denominator. So it's the square root of 2, so we will multiply both the top and bottom by the square root of 2. Because when we multiply these two square roots, the square root's going to go away. Right, multiplying across, we have 11 times the square root of 2. Multiplying across the bottom, that just equals 2. Right, now, once again, remember, we cannot cancel out 2's in a situation like that, like this, because that 2 in the numerator is not really 2. It's the square root of 2. Okay, here we have 5 over the square root of 5. We are not allowed to leave square roots in the denominator. So we multiply the top and the bottom by the square root of 5. Because the square root of 5 times the square root of 5 is just 5, which helps us get rid of that square root in the denominator. Okay, multiplying across the top, we get 5 times the square root of 5. Multiplying across the bottom, the square root of 5 times the square root of 5 equals 5. All right, we have a lot of 5's in here. And notice we do have two regular 5's, one in the numerator, one in the denominator. And 5 divided by 5 is 1, so we can actually cancel those, leaving us with the square root of 5. About simplifying with square roots have been helpful. This is Mr. Ela, signing off.